Okay, students, we're going to go ahead and look at problems from each page here. First one, tangents to circles. We know a tangent by definition is a point from outside the circle and goes to the circle and only touches one time. Even if I extend it, it's only touching one time. Okay, that's called a tangent. A tangent, if it is a tangent, it is always 90 degrees to the center of the circle. So I immediately put in 90-degree angles on all the tangents. Okay, now we're trying to prove if it's a tangent or not. If it is, since it's a right triangle, it has to be a Pythagorean, it has to satisfy the Pythagorean theorem. Now notice from here to here is 12. That's also a radius, so this must be 12. Remember the hypotenuse is across from the right angle, so we have a 12, 16, and a total of 20. Now the question is that Pythagorean triple? If I divide each of those by 4, I get 3, 4, 5, which is a Pythagorean triple. So that's a multiple of the 3, 4, 5. Okay, that saves me from having to do 12 squared plus 16 squared to check if it's 20 squared. Okay, here I'd be doing 6.6 squared plus 11 squared. This 11, since it's written in the middle, that means that's the whole length is 11. Okay. 11 squared equals 13 squared. 13 must be this. Yeah, it shows us the entire length. Okay, so I'm now checking if that satisfies the Pythagorean theorem. Okay, so that's what you're doing on all of these here. Now it says find the segment length indicated. That's all the question marks. So again, assume the lines which appear to be tangent or tangents, and I could say assume the segments as well. So that is true. Now it wants the whole length, so we just call it x. So we have 4 squared plus x squared equals 8.5 squared. Okay, and you solve it for x squared. I mean, you solve for x. We're trying to solve for x. So subtract the 16 across, and then take the square root. Okay, here, right triangle. So again, we have 12, 16. We know this must be 20. We just did it up there in number 1, 12, 16, 20. Okay, so that length has to be 20. All right, next page. Perimeter of each polygon. Okay, so when I have a tangent, a point outside the circle and it's tangent in 2 places to the circle, those distances are congruent. So those 2 are equal. From this one, it's tangent there and tangent there, so these 2 must be equal. And those 2 tangents must be congruent. Okay, so now they gave you this is 11.2 here, so this must be 11.2. Well, the whole length was 23.2, so that means this has to be 12, which makes this has to be 12. Since this is 10.5 over here, this has to be 10.5 right there. Now I can just add up all those lengths, and I have the perimeter of the polygon. Okay, so you do that for all these problems here. Find the angle measure indicated right here. Okay, well, don't forget, these are both radii. So that means it's an isosceles triangle, which means the base angles are equal. So that makes this 63 right here. Okay. 63 and 63 is 126. 126 from 180 is 54. So it puts this at 54 right there. Now, don't forget then that since this is a tangent, if it appears to be tangent, they're tangent, that means this is 90 degrees. So now I have a picture of the big triangle right there. Okay, I have 90 there, plus the 54 there, plus x, oops, plus x, not times x, equals 180. Or since that's 90, I know these two have to be complementary, reviewing our vocab words of complementary. So I could just go 90 minus 54, which gives me 36. So that right there has to be 36 degrees. Okay, so that's what you're doing on these. Don't forget, if you have a, since these are 90s, since they're tangent, now I have a quadrilateral. How many degrees is a quadrilateral? 360. So I have 3 of the 4 I can subtract. Okay, next. Secant angles. Okay, notice these two chords, which if you extend them, go through them, they'd be secants, but through lines. That's why they're just called them secant angles. To find the angle here, which is going to be equal to that angle there, I take the sum of the two intercepted arcs, that's the 175 plus the 55, and divide by 2. And there's my work right there. So I get 230 divided by 2 is 115 degrees. So 115 for that angle and that angle, since they're vertical angles. When I have the angle outside, so that's when the angle is inside the circle, and the angle is outside the circle, it's the big arc or the outer arc minus the small arc or the inner arc divided by 2 equals the angle itself. Another way of saying that, I could say outer arc minus inner arc or big arc minus small arc equals double the angle. So I just recalled um, measure of angle R is X. So I did 2X. So it's time to rewrite measure of angle R each time. Just called X. So big arc, 140 minus the small arc, 50 equals 2x. 90 equals 2x divided by 2, and x equals 45 degrees. Remember, x is the same as measure of angle R. All this is on your DCAS sheet as well. Okay, don't forget here we have just an inscribed angle. So we know an inscribed angle is half of its intercepted arc. So half of 194 is 97 degrees. Okay, down here is more with intercepted inscribed angles. So that's 70. We know this is double that, 140. That's why I set this algebraic expression equal to 140. Solve it. Add the one across. 140 and 1x equals 141. So x equals 1. Okay, so here we have the secant. Big arc minus little arc equals double the angle. Double the 50 is 100 degrees. And then solve that. Okay, here we have more of the same with algebraic expressions again, so that's nothing new. You've seen examples of that. Okay, here it says find the measure of arc KLM. Okay, well, so KLM well, is this right here, KLM. Well, if I find this arc right there, I can subtract it from 360. Let me change the color of that. If I find the measure of that arc, I can just subtract it from 360 because the circle is 360 degrees, and then that would be the measure of arc KLM. So don't forget, I have 5x minus 1, that's the inscribed angle. If I double that, that makes it 10x minus 2 has to equal its intercepted arc of 8x plus 14. Subtract the 8x across gives me 2x. Add the 2 across gives me 16. So x equals 8. So now if I plug 8 in there, 8 times 8 is 64, plus 14 is 78 degrees. So now I just got to go 360 minus the 78 degrees to 282. So the rest of it, measure of arc KLM, is 282 degrees. There's my answer. Okay, so make sure that you're answering the right question. Okay, remember for here, that's that angle right there. This arc plus this arc divided by 2 equals the 8x plus 16. Solve it. Get your x, plug it back in. We only want BC, so you only want that length. So after you get your x, you just plug it into that one right there. Okay, next. All right, lengths now of tangents and secants. Okay, anytime I have a tangent, anytime I have a tangent, I'm going to square it. So there's a tangent right there. And if it's a secant, right here, remember secant goes through twice. It's the outer, which is the 9 here. One outside the circle, that means, times the whole length, 9 plus x. So the tangent is squared, so 15 squared equals the outer segment, 9, times the whole segment, 9 plus x. Okay, then you can go ahead and solve that for x. So that's what you're going to do on all these. Anytime, if you have two secants, it's outer times whole equals outer times whole. Anytime it's a secant, it's outer segment, the one outside the circle, times the whole segment. Okay, anytime it's a tangent, you're always squaring it every time. Okay, the next type you have here, if I have two chords, okay, here's two chords. I take the individual pieces of those two chords, so x times 4 gives me the 4x, and I take the other two individual pieces, 5 times 8, and multiply those together. Okay, notice I did not go ahead and multiply out the 5 times 8. I just divided by 4 right here, and the 4 will cancel the 8 2 times, and I get 5 times 2 is 10. That just keeps the numbers smaller. Okay, in case they have any bigger, I'm just canceling down smaller right now. Okay, next page. We have the same thing again. Be each individual piece multiplied together equals the other two individual chord pieces multiplied together. This is just more practice of all of it put together on this page. Okay. I did one here, 16, where I'm dealing with a quadratic, because when I take these two pieces, 6x times 12x, that gives me 72x squared, and then 8 times 9 is 72. Okay, divided by 72 on both sides, I get x squared equals 1. Remember, in a quadratic, the reason I picked this is a quadratic tells me I have two answers. It'd be x, technically I'd have x equals plus or minus 1. But when I check the negative 1, that would give me a negative 12 there, a negative 6 there. I can't have negative actual lengths. So that wipes out the negative 1. Okay, wipes out that. Can't equal negative 1 because it'd be unreal, you know, for a real life problem. So x equals 1 works, but x equals negative 1 doesn't work. I point this out when one of your solutions doesn't work, it's called extraneous. Make sure you memorize that. You'll be using that multiple times in algebra 2. You also see in pre-calc as well. Okay, and that does it right there. 12 and a half minutes.